Hey everyone, I'm Jeremy McPeak and welcome to this third installment of ASP.NET from scratch. Before I started this series, I wrote out a lesson plan, and this third part was going to cover Microsoft SQL databases and ADO.NET, which is a set of classes that we use to connect to databases. As I was going over this material, I realized that there were some fundamentals that we needed to cover before getting into ADO.NET, and that primarily that is interfaces. It's a object-oriented programming concept that we're going to cover in this part. But before that, we need to talk about class inheritance. So we're not quite done with kind of what we started with the second half of part 2, which was looking at C# and some of the .NET framework. So I haven't written a script, I haven't rehearsed anything, I'm flying by the seat of my pants. So if there are some uhs and some ums, I apologize up front. I'm going to try to keep those at a minimum. To cover these concepts, I'm just going to get straight into the code. So I'm going to start up Visual Studio 2008 Professional. I'm using Professional because there are some features that come in handy when dealing with interfaces, and I want you to see that. If you are going to get into .NET full-time, or if you're going to be a serious hobbyist, I recommend that you purchase the Professional version because it's going to have everything you need. Of course, if you are a student, you can download it for free from dreamspark.com. We are going to write a theoretical application, and what I mean by that is it's not going to do anything. It's going to have code. That code is going to have classes, and those classes will have properties and methods, but it's not going to do anything. Everything is going to be in pseudocode, and even that is just going to be in comments. This particular application is going to emulate vehicles and allow us to control them. I'm going to call this project vehicles. And the vehicles are actually going to be represented by different classes, and then we're going to have another class called a vehicle controller that will allow us to control vehicle objects. The first vehicle that I'm going to write is going to be an automobile, and it's just going to be called automobile, and it is going to be public. We're going to add 3 methods. The first is going to be called accelerate. The second will be decelerate. And the third will be change direction. These are the 3 primary things that we need to know in order to control just any type of vehicle. We need to know how to accelerate, decelerate, and change direction. Something else that we can add is a property to get the direction that this vehicle is currently going in. So we can add a property. I'm going to use a snippet, and snippets are a feature of any version of Visual Studio. They all pretty much have the same basic snippets. There's one snippet called prop. To use a snippet, you simply type the command for the snippet and then you hit tab twice, and it'll automatically put in the code that is linked to that particular snippet. So here we have a property, public, and int is the default, but we can change it to decimal, which is what we want to do. Then we'll hit tab to go over to the next field here, and we are going to change this to direction, and then to finalize we'll just hit enter. Now this property looks different than the property that we created in the second half of episode 2. Back then we had a private field of the same type, and it would have an underscore and then the name of the property. We'll give this a value of 9. So, and then we would have the get accessor get the value of direction, of underscore direction, and then the set accessor would set a value to underscore direction, and we could have some type of validation if we wanted. Well, with .NET 3.5 they gave us the ability to shorthand properties like this, and of course this really isn't doing much here. This is a simple property. It's just a plain get and set. If we wanted to add some validation or things like that, then we would have to, of course, write some more code. There's also a different snippet that will actually work better for us here, and it is prop G. And what this will do, we'll go ahead and set everything here. This sets the get accessor as public, so anybody could get the value of direction. But the set is set as private, so only this automobile class could set the value of direction. So in our code, we would just simply use the name of the property and set a value, or whatever we wanted to do, or get the value. The compiler keeps track of these types of properties, so we don't have to worry about it. All we have to do is just code with this name here, and everything is just fine. Now I wanted to set this as private just simply because an outside source doesn't need to set this direction. If we want to change the direction, we have to change direction for that. This is just a design choice. If we wanted to get rid of the change direction method and just go with direction, that's fine too. But I'm just doing this for this particular example. If we wanted to get a little bit more detailed, and we would if we wanted to build a real life application like this, we would actually have other objects. For example, we would have an engine object, so that if we called the accelerate method, this engine object would probably be made up of a lot more components that represented all the components that make up an engine to propel the vehicle forward or backward. The decelerate would probably use a brake object, and it would also communicate with the engine object so that we could start getting less gas into the engine. And of course, to change the direction, we would contact the wheels. So we would have wheel objects so that we would need to turn the wheels a specific direction in order to turn the vehicle. Now in this exercise, we're going to stay away from getting too detailed. We want to keep things very simple. But keep in mind that this detail would normally be there because it's going to come into play whenever we start talking about inheritance in a few minutes. Since we have a vehicle here, we have an automobile, I'm going to create a class called Vehicle Controller. And it will allow us to control the vehicles that we pass to it. It's going to have a private field of type automobile, and I'm going to call it underscore vehicle, and I'm going to set that as null. We are going to have a constructor, and it is going to accept an automobile object. We're going to call it vehicle, and inside of the constructor we are going to set our private field underscore vehicle, the value that is passed as a parameter. We're going to add three methods: public void go, in which we will call the accelerate method, then we'll have stop, and we'll call the decelerate. Alright. And then we'll have a method called turn, and we'll call the change direction method. So to use these classes, we would go to this program.cs file. And the static void main, this is the main entry point of any C# application as far as Windows is concerned. So any code that we put inside here is going to execute. So the first thing we need is an automobile object. I'm going to call it vehicle, and we'll create it as a new automobile. Then we need a vehicle controller. I will call it controller. I'll call the constructor. We'll pass it our automobile object. So then we could make our vehicle go, and we can make it turn, and of course we can make it stop. So now we can control just about any vehicle as long as it's an automobile. But if there's one thing we know, it's that not all automobiles are made the same. Of course, in this particular example, it really doesn't matter because we could just use automobiles all day long. But in a real-world example, we would have an automobile, but then we would have more specific classes to address other vehicles like an SUV or a truck or an 18-wheeler. They all have the same basic implementation as far as having an engine to propel the vehicle forward or backward, and they have wheels to turn the vehicle. But other than that, and other than size, there are going to be some discrepancies. And one such discrepancy is an SUV. They used to be notorious for flipping over if you were going to turn at a high rate of speed. And some manufacturers started implementing some type of counterbalancing systems in order to help keep the SUV from tipping. So let's say that we want to write a class that represents an SUV with this counterbalancing system. So I'm going to add a new class. I'm going to call it SUV, and we'll set it as public. And since an SUV is an automobile, we want to take advantage of all the code that we have written within automobile, because we don't want to rewrite, how to accelerate and decelerate and change direction and all that wonderful stuff. So what we are going to do is we are going to inherit the automobile class. And to do that, we simply type a colon after our class name here, and then we type the name of the class that we want to inherit from. So now we have an SUV class that inherits from automobile. In fact, we could go to program.cs. We could swap out the automobile with SUV, and everything would still work fine. In fact, I'll go to build, and you can see that the build succeeded. That's because all SUV objects are automobile objects. So we have SUV, and it is an automobile, therefore we are inheriting all of the base implementation of automobile. So we want to take advantage of our counterbalancing system whenever we change direction. Well, one thing we could do is we could write a new change direction method. But that's not very efficient, and it's not very smart, because we would have to rewrite all of the code that we had within change direction. So instead, what we want to do is we want to override. And we use the override keyword, and we'll hit space, and IntelliSense will tell us everything that we can override. And we can see here that we can only override equals, get hashcode, and toString. These are actually inherited from the object class. So we're not seeing the items that we want to override, which would be the accelerate, decelerate, the change direction methods, as well as the direction property. So in order to get those into our IntelliSense, we need to go back to automobile.cs, and we need to mark these members as virtual. And by doing so, we are telling the compiler that these methods and this property can be overridden in inherited classes. So if we go back to SUV and we hit space, now we can see that we have accelerate, change direction, decelerate, and direction members that we can override. So the member that we want to override is this change direction, and whenever we double click it, Visual Studio automatically adds in this code here, this base.change direction. Base in this case refers to automobile. So essentially what we have here is we are using the implementation that is used within the automobile class. So if we were to call the change direction method as it is now, then we don't have any custom code in here, so our SUV would just turn. So we could add in some code to engage the counterbalancing systems. So that would engage those systems, and then we would change direction. If we were to comment this line out, then our SUV would engage the counterbalancing systems, but we would just keep going in the direction that we were going because we have told it not to change direction. So we do want this code here. So with these changes, we could go back to program.cs. We could once again change out automobile with SUV, and everything is still going to work fine. We can build it and it will build successfully. And whenever we called the turn method of our controller, which in turn calls the change direction method, since this is an SUV object that we pass to the constructor, then we are calling the change direction of SUV. It is engaging the counterbalancing systems, and then it calls change direction of automobile. So everything works fine. We haven't changed anything as far as what the vehicle controller class is concerned with. This is pretty good design here. The only problem is if we wanted to add a different type of vehicle, such as an airplane, we would have a hard time doing that because logically an airplane cannot inherit from automobile. And in our code, in a real world application, that would be impossible as well, since they are completely different, they have completely different components, and they operate completely differently. So what I'm going to do is I'm going to create a new class, and this is going to be a base class for all fixed wing vehicles. And I'm just going to call this fixed wing vehicle. We'll make it public, and just to save some coding time, I'm going to copy and paste here. So we have an accelerate, a decelerate, a change direction, and a direction property. These three methods here all use objects that would be used by this fixed wing vehicle. If we wanted to control these fixed wing vehicles, we could go back to our vehicle controller class. We could add in another constructor, and it would accept a fixed wing vehicle object. And then we could have another private field of type fixed wing. And then we could even add some logic into the go, stop, and turn methods to determine what object that we have here. Because automobile and fixed wing vehicles are two completely different. We would have to determine which one was null, which one had a value, and then how we would use that object. So doing it this way, we have just added a lot more complexity to our code. It's a lot harder to maintain now, and we have to go to extra steps in order to add even more types of vehicles. If we wanted to add some type of nautical vehicles, we would even have to add more code for that. So thankfully, we have something called an interface. An interface is an object-oriented programming concept. You can think of it as a contract. Any class that implements an interface has to implement the properties and methods that are declared within that interface. And one of the features that I wanted to show you of the professional edition of Visual Studio is how easy you can create an interface. I'm just going to right click here. I'm going to choose refactor, and I am going to extract interface. Now this particular feature is not available in the Express editions. There is extract method. If you wanted to extract whatever you had highlighted as another method, you could do that. Extract method and rename are the only refactoring tools that are available in the free versions. So I'm going to choose extract interface, and it's going to ask me what I want to name this interface. I want to name it iVehicle because this is going to be used by all vehicles. The uppercase I means that this is an interface, and then the name after it is just saying that this is a vehicle interface. Public members to form interface, I want to select all of these, and then I'm going to hit OK. So this automatically created an interface for me. I'm going to put public in front of interface. And if you were going to write an interface, this is how you would write it. It would have an access modifier, in this case public. It would use the interface keyword and then the name of the interface. In this case, it's iVehicle. And then you would declare the properties and methods that you want this interface to have. There is no code within an interface. It's strictly just declarations. So we have void accelerate, we have void change direction, void decelerate, and then we have a decimal of direction. And we have set this, well, Visual Studio has set this as having only a get accessor, but we could add a private set if we wanted to. Let's go to the automobile.cs file, and we can see that Visual Studio added in vehicles.iVehicle here. I'm going to take off the vehicles namespace because we really don't need it here. In order to implement an interface, use the same syntax as you do as inheriting from a different class. But it's not called inheriting an interface, it's called implementing an interface. So it's the same syntax, but it's different semantics. We didn't have to do anything else here since we already had implementation of all of the methods and property within the iVehicle interface. Since it was already implemented, we didn't have to do anything here. But if we wanted to do the same thing to iVehicle, or the iFixedWing vehicle, we'll add a colon and then we'll add the iVehicle. Visual Studio will prompt us to implement this interface or explicitly implement this interface. If we choose explicitly, it's going to prepend the method and property names with iVehicle. Some people like that, I don't, so I'm just going to do implement. This is the default implementation of whenever Visual Studio implements an interface for you. It will put all of the members inside of a region. A region starts with a pound sign, and then region, and then the name of the region, and then the region ends with pound sign in region. And what this allows you to do is collapse this entire region of code. So if you have a large code file that you wanted to organize a little bit better, you could use regions if you wanted to. Something else that Visual Studio does is it adds in the throw new not implemented or not implemented exception. So if we tried to use these methods here and this property, our code would actually throw these exceptions because these are not actually implemented yet. We have them in our code, but it doesn't do anything. So I'm just going to comment these out. And something that we have to do with this property, since it returns a decimal type, we have to return a decimal here. So I'm just going to return 0. So here we have fixed wing vehicle that implements iVehicle. We also have automobile that implements iVehicle, and thus SUV implements iVehicle as well. So we could go back to our vehicle controller class and we could change the automobile references to iVehicle. And so any class that implements the iVehicle interface can be passed to this constructor. We can save it to our private field that is of type iVehicle. And since all iVehicle objects have an accelerate, a decelerate, and a change direction method, we can call those methods without having to do any type of validation or checking, because the compiler will not compile if a member is not properly implemented. To show you this, I will go back to fixed wing and I will delete the direction property. If I go to build and build solution, we can see that vehicles.fixedWingVehicle does not implement interface member vehicles.iVehicle.direction. So our code will not compile if our classes do not completely implement the interface. So now that we have added back in direction, if I go and build, then we get a build succeeded. And we can test this by going to program.cs and swapping out SUV with fixed wing vehicle. And if this wasn't going to work, then the compiler would tell us, but the build succeeded. That's because fixed wing vehicle implements iVehicle, and also SUV does because it inherits from automobile, which implements the iVehicle interface. So this is primarily where I wanted to get to, is interfaces. An interface is a contract. If you have a class that implements an interface, you know that that class is guaranteed to implement the properties and methods declared within the interface. Interfaces are an abstraction, and the more abstractions that we can use within our code, the more our code is flexible and maintainable. Just as this application, even though it's very simple, it's very flexible in that we can write classes for whatever vehicle that we want to control. As long as it implements iVehicle, we can use it within our vehicle controller class. So interfaces are a good thing. And we'll see that more as we start looking at ADO.NET in the next part, and even beyond that whenever we start looking at Microsoft's Link technology. Before we stick a fork in this, let's go to the View menu and we'll open the Object Browser. Now, the Object Browser is a handy little feature. It is in every version of Visual Studio. It's not just for the Professional Edition. What this is it displays all of the components within the .NET framework and within our particular solution here. Right now we are browsing all components, but we could break it down into .NET 3.5, 3.0, 2.0, or we could just look at the components within this particular solution. One thing I want to show you is the system.data namespace. This is primarily ADO.NET. The ODBC, the OLEDB, and the SQL client are namespaces that contain classes that we use to connect to databases. There are also third-party ADO.NET providers. One such is one from MySQL. They wrote one that is very handy, and it follows the same design patterns as what you will find within ADO.NET. Of the ODBC, if you are using an ODBC driver to connect to a database, you would use the classes within the ODBC namespace. If you are connecting to an Access database or an Excel spreadsheet, you would use the classes within OLEDB. And the SQL client is for Microsoft SQL Server. Let's open up the ODBC namespace, and this ODBC connection, if we go to base types, we can see that it inherits from a DB connection, which implements the IDB connection interface. So ODBC connection is guaranteed to have these properties and methods. If we go down to SQL client and look for the SQL connection class, it too inherits from DB connection, which also implements IDB connection. So we could even write a data access layer in abstractions, and then we could supply that data access layer with classes such as SQL connection or ODBC connection, and we could have a flexible application that could connect to a variety of databases, which is very handy. Also, something else, we have used interfaces. I just didn't tell you about it. If we go to MS Core Lib and go to system.collections.generic, we can see the IEnumerable interface, and pretty much every collection here implements either IEnumerable or IEnumerable T. And this particular interface here is a generic interface. If you see T like this, it is a generic. We're not going to talk about generics yet. They are pretty handy, but the IEnumerable interface allows us to use the for each loop. We used it in the previous episode whenever we looped through the controls collection. Since the controls collection implemented the IEnumerable interface, we were able to use the for each loop, and you can only use the for each loop with IEnumerable collections. So anyway, that is class inheritance and interfaces. In the next part, we're going to look at SQL Server and start looking at ADO.NET to connect to SQL Server. So thanks for watching, and we'll see you next time.